In this episode, I want to make my first steps with Fibre Channel and storage area networks, and I want to access a Fibre Channel storage array from HP with my AlphaServer DS10 via OpenVMS. Hello viewers, welcome back to another episode, and this episode is about Fibre Channel, or building a storage network, or SAN, or storage area network. And I really don't know if this is a storage episode or this is a network episode, because if some kind of both, storage and network, but I decided this is a storage episode, so this is StorageWorks part 4, but you do not need to view all the previous parts, but if you're interested, they are linked down below. Yeah, and Fibre Channel was really expensive back then, so these are my first Fibre Channel parts, so I've never touched Fibre Channel before. This is basically my first experiment with Fibre Channel. And with Fibre Channel you can build a network with some nodes and some switch. So this is a switch, and this is some Fibre Channel storage, and you have servers. And in contrast to direct attached storage, you can use some kind of network. So there's no direct attached storage like a SCSI connection to a server. It's built like a network. And there's also some kind of layer architecture for Fibre Channel, but I won't go into detail. It's a bit like OSI, but this is very deep and not necessary to understand the basic function. And also basically Fibre Channel uses fiber as a media, so these are fiber connections here, and also this has a fiber connection on the back, but it uses SCSI commands. So for the server it just looks like direct attached storage, but it isn't direct attached. It's connected via some kind of network. And there are also different generations. I don't know which is the actual generation, because current stuff is very expensive. But here on the left, especially these switches here on the left, these are first generation Fibre Channel, so it's called 1G Fibre Channel, and 1G also stands for 1 gigabit, because these are 1 gigabit components here in this switch. But you normally you have a look at the nominal throughput, and this is 100 megabyte per second with Fibre Channel 1G. And interesting is, Fibre Channel is supported in OpenVMS as a cluster technology since OpenVMS 7.3. Obviously not in VAX, but in Alpha and Titanium, and I think also in x86, but I never tried OpenVMS on x86 yet, but in Alpha it's supported. And I've also got some components up to 8G here, but this is some stuff for later projects. Maybe I will do some kind of Fibre Channel things with my Titanium later, but this is not a topic of that video. And as I said, the 1G uses normal network hardware. So in the switch you can see these GBICs, and these GBICs are just a normal multi-mode 1000 base X network GBICs. They are also able, you can also put mono-mode stuff in there, but these are just standard network GBICs. One interesting thing is I can convert my enterprise storage array that you've maybe seen in one of my previous episodes with HFZ70 StorageWorks controller to a Fibre Channel enterprise storage array. So I can change the controller to two HSG80s, and I have that controllers. Then this is connected via Fibre Channel. Maybe I will do that later. I really don't know if I will do that, because there is a manual which describes the conversion from the HFZ70 to the HSG80. But it's not. When you have a look in that manual, you can see different operating systems, but OpenVMS is not described in that manual. So maybe the conversion is not supported by OpenVMS, and I have to install OpenVMS again. But it's possible. Then I will make a backup and so on. But another problem is you have to change some other parts. You need new cache modules, but I also have the new cache modules, but not the memory sticks for it. You need also GBICs for that specific HSG80. Interestingly, these GBICs are made by IBM, but I'm still missing one GBICs. You need 4 of them, and I only have 3 of them at the moment. But maybe later I will convert this enterprise storage array to a Fibre Channel enterprise storage array, but this we will see in another video. First of all, I want to build in some Fibre Channel controllers into my alphas, and before I continue that video, we will see the controllers and the built-in process of that controllers. Here are my controllers. The Fibre Channel controllers. On the left you can see also FTDI controllers, but this is another video. I think it's already released when you see that video, because that video is I record the videos in parallel, but yeah, I think the FTD video is already out when you see that video here. But let's talk about that controllers over here. You can see these are PCIX controllers, so 64-bit connection. And here is one fiber connector, 1G Fibre Channel connector, and they are called KGPSA-CY, but this is the typical DEC naming. K stands for storage controller, G for Fibre Channel, P for PCI. I think I do not really know what S stands for, but I think it stands for single, because it's a single connector, and A is the revision or generation. And I have bought, I have in total 5 of them, but 2 of them are for several months built into my AlphaServer DS10, so there are 2 of them already installed. And I've bought 3, another one, and one spare, and the other 2 will be installed in the AlphaServer 800 now. I can only install one in the AlphaServer 800 because there's only one PCI-X slot. Maybe they will work also in a normal PCI slot, but I will install it in a PCI-X slot, and there's only one PCI-X slot in the AlphaServer 800, so I can install only one of them in each server. So let's install the controllers in the AlphaServer 800. So I've built in the controllers into the alphas. And what's here on my desk, you can have seen it before, and so the whole video except of the built-in part of the controllers, you can see different things here. And on the right, this is an HP StorageWorks Modular Smart Array 1000 or MSA 1000. This is quite cheap thing, and I've bought it just for testing purpose, to test Fibre Channel, because I do not want to convert the enterprise storage array to HSG80, and I need some Fibre Channel attached storage for my tests here. It's a bit broken here on the left. One of these screws is missing, and it's a bit bended here, so I think it felt on the left side. Maybe that was the reason why it was cheaper. And also here, this piece of plastic, this red one, is missing for the left controller, but it's working. You can see there are 2 controllers inside. There is a cache module inside with 256 megabyte of cache. The right module showed an error on booting. We think the battery on the cache is broken, but it starts. The cache module looked like a bit like a memory stick with a battery direct attached on it, but it's possible to get new batteries, so it's not a problem. At the beginning there was an issue with the cache, or the cache size, because the left controller had only 128 megabyte of cache, and then when there's a different size of the cache, one controller will disable. But I was able to get a new cache module with 256 megabyte of memory, and now both controllers are working. And I've installed 10 146.8 gigabyte SCSI hard drive in that array. You can see there are 5 on the left and 5 on the right. It's the reason because 7 disks. The first 7 disks are on one SCSI channel, and the right 7 disks are on another SCSI channel. So both controllers, each controller has 4 SCSI channels, and you can expand the MSA 1000 with 2 expansion units as well, so up to 42 disks. And that's the reason because there are some distribution between 2 of the channels I've put 5 disks on the left and 5 disks on the right, and I've tested the hard drives also before a bit on Windows 2000, because I also got a Compaq ProLiant server with 18.2 gigabyte hard drives, and I've got the server needs 2, and I've had 5 of them, and all of them were broken. And now I will test older hard drives before I will put them into some kind of hardware, because I have to reinstall everything on the server again. So yeah, that's the reason I've tested everything. It takes about it took about 3 days to test these 10 hard drives. So yeah, that's the reason why they are tested before. And I've configured the hard drives as called ADG in the configuration, Advanced Data Guard, but basically this is RAID 6. And you need also some special cables. So this is not a normal RJ45 connection. This is called RJ45Z. I really don't know why HP uses this special connector. I have to remove a bit from the plug to get it in there. And this cable I've made, this cable here on the right, this connector is this RJ45Z connector, and I've put a DEC connector on the other side, so I can convert everything to DEC, because the DEC connection is do not have to think on zero modem connections and all that stuff. So it's quite nice to convert everything to this special DEC connector. And you can configure that module via CLI, like the older DEC StorageWorks components. But I think this CLI is much simpler, so it was much easier to configure this device like the configuration of the HSZ70. And also I thought when the disks are inside and I've built the array, it will take 2 days to build the array. No, the HSZ70 when I built the RAID 5 array in my HSZ70, it took about 9 hours to build the array, because the HSZ70 checks all the disks, I think with the parity and so on. This thing does not do that thing. This array was created just in time. I hit enter and then the array was created. And in the back of that thing is also a fiber channel switch, but I won't use it because I have these fiber channel switches here on the left. And these are really interesting because you can see the color. This is the late 90s DEC blue. It's written Compaq on it. Compaq StorageWorks fiber channel storage switch, they are called. They are the same blue like the enterprise storage array and my cabinets. So this is the color of the time for that kind of hardware. And there are 2 different versions. This is an 8-port version and this is a 16-port version. They are not made by Compaq, they are made by Brocade. When you have a look inside, you can see written Brocade on every chip inside. And the only difference is there are boards inside, and each board has 2 ports, and here are 4 boards inside, and here are 8 boards inside. I think when you can buy these boards, you can expand this top switch also to a 16-1. Then here's a network connection, and here's a display. We will see it later, and you can configure some things on the display. But there's also a possibility to configure it via Telnet, also via there's web configuration utility available for that switch. In the manual, I think these are the first fiber channel switches made by Compaq for that kind of hardware, because you can see in the manuals they are made for the HSG80. So this is all this is the era and the technology all for that stuff. But the MSA1000 supports, so this is 1G, and the MSA1000 supports 1G and 2G. So I hope that will work. Also the controllers are 1G controllers, so I hope that it will work, but we will see that. And there are also different kind of ports in fiber channel. They're called F ports and N ports and FL ports, but normally a switch auto detects which kind of hardware is connected. So if it's server connected or another switch or some kind of storage hardware. So I don't have to go into details in these kind of ports. And it's not really necessary to use switches here because there is a switch inside of the MSA-1000, but I will use them because I have them and I will use both. It's also not necessary because only one of my alphas has 2 fiber channel cards inside, but because I have 2 switches, I can use 2 switches, so why not? So what is the plan? I will build the storage area network with my 3 alphas, and I've put one controller in each alpha server 800, and there were 2 controllers in the DS10 for several weeks now, and I will connect it to these 2 switches here on the left. So there are fiber connections from the alphas, 10-meter cables from the alphas to the desk over here. And then I will link also both switches together. I hope that will work when I put a cable from this switch to the switch, maybe, I don't know. And then I will connect both switches to the MSA-1000. So let's connect everything, and then I will start the cluster or the alpha part of the cluster. And then we will go into SRM and OpenVMS, and let's see if we can access the MSA-1000. Now everything is connected, and as usual, nothing works as planned. So first problem, or the one problem, or the only problem was that here on the back there are switches, and these switches won't communicate with these switches. Over here there is an indicator light, and it said that the connection is segmented, or the port is segmented, but it's only in one direction. So you can see here the configuration of the internal switch, and the internal switch is also made by Compaq, and like this device here. And this device detects the connection correctly as an E-port, but it's not working the other way around. Yeah, that's the reason why I disconnected these two switches at the moment, and I connected only the DS10, because for obvious reasons, we will see that, only the DS10 directly to the switch here on the back. But there was the next problem. You can see there are 5 connectors. This is a 6-port switch, and the 6 ports is the internal port. Only these 4 connectors are fixed or integrated, so you cannot change the ports. And this is a normal SFP port. On this port, there is no connection possible to the KGPSA controller. So it starts blinking between 1G and 2G, and there's no connection. I can only use the SFP, but not with all SFP modules. So I have quite a lot of SFP modules here. And I have to use these Brocade 4G modules. And with the Brocade 4G modules, it is working. So the connection from the DS10 to the switch. You can see here, this is the SRM of the DS10, and here the Compaq MSA-1000 is detected. I've started the cluster. The two AlphaServers anodes are running, and also one rack, so there are enough rows. And I will boot now into OpenVMS, and we'll see if there's any detection of any kind of volume. And then, if there is a volume, I will initialize the volume. Another thing I forgot to mention about these MSA-1000 is I said the CLI is quite simpler than the HSZ70. There's no shutdown command for the controller, so the HSZ70 I have to shut down, otherwise next start it will beep and shows errors because the cache issues, etc. You can simply turn off the MSA-1000. I don't know what's happening with the cache content, but it's possible to turn it off and on, and it's not any problem. Okay, another thing I've also done is I've added the connections here on the MSA-1000. You can see here both controllers of the DS10, and I've added a connection because I can set the profile name to the operating system, and I said this is OpenVMS, so that the controller can handle the OpenVMS connection, I think, because you know that OpenVMS is accessing the controller and not Windows or something like that. So now I will boot OpenVMS here on that machine, and then I will have a look if this is working or not. Okay, now it's working, but it's the next day, and it was a complete disaster to bring it to run. So it took me hours and hours, and it also destroyed OpenVMS installation. But let's talk the story in detail. First, there is a tool called WWID-MGR, which is the tool for the configuration of the Fibre Channel adapter, and it writes some data in the non-volatile RAM, so it's necessary to do some configuration in that first. And for OpenVMS, you have to set the ID. It's called UDID. And this UDID sets also the number of the, you can see it here, these are the number of the devices. So $1 is the allocation class. The allocation class is always 1 for hard drives, and it's 2 for tapes. And then DGA is a Fibre Channel hard drive, and then this number after that, 201, this is the UDID. And when the controller does not distributes such an UDID, it's set to -1, and you have to set it via the WWID-MGR tool. But I've set the IDs to 201 and 202, and the hard drives were visible in SRM. but I didn't saw the hard drives in OpenVMS. The installation, the OpenVMS version was 7.3-2, and normally 7.3-2 has integrated Fibre Channel support. But the first array I've created on the MSA 1000 was a RAID 6 array with precise about 1.12 terabyte. And normally the limit of FILE11 is 2 terabyte when it's used unsigned for addressing, but I think 2 terabyte is the maximum volume size for FILE11. But I thought, okay, maybe it's 1 terabyte, and I've created 2 smaller RAID 1 arrays. These are, you can see here, these are the 2.1 DGA 201 and DGA 202. These are 2 RAID 1 arrays with 146 gigabyte each. But that was not the case, so later on I will try to build the bigger RAID array again. But there were some patches released for OpenVMS and Fibre Channel, also for the version 7.3-2, and so I thought, yeah, okay, let's install these patches. And then the next thing happened. I've installed the patches, and that broke my installation of OpenVMS 7.3-2. Yeah, and after that, I said, okay, that's the end. I do not really want to install OpenVMS again. But I've installed another newer OpenVMS version 8.3. But there was the same behavior. OpenVMS 8.3 didn't detect the hard drives. And then I've removed the second controller because maybe this is a redundancy problem, but the case was, when you have a look over here, this is the configuration, you have to set these unit identifiers in the CLI. These unit identifiers are the UDIDs, and when these unit identifiers are not set, OpenVMS cannot detect the hard drives. So it seems to be necessary to set them into a CLI. So now, yeah, you can see there are the two hard drives, and I've initialized them, and the volume FC1 for testing, and I've created a directory, so it's perfectly working. So as a last test in the video, now I will delete these two hard drives and will make the big RAID 6 array. I will create that again, and then I will try out if it's possible to see that array in that machine. Okay, yeah, I've rebuilt the original RAID 6 array, and the RAID 6 array is there. You can see here, because it's bigger than, it's quite big, it cannot show the 3 blocks. There's only this kind of it seems to be a too big number of for the 3 blocks, but I was able to create a volume on it. I've created as an ODS5 volume, and I've named it FTP storage. There is a reason, because I will further on make a video about a web and FTP server on OpenVMS, and therefore I will use that thing for some storage for that stuff. That's the reason why it must be ODS5. And it's called FTP storage, and this is there. Interestingly, now the MSA 1000 starts to build the parity, so it's 0% at the moment. I hope it is finished in the next 24 hours. Otherwise, I have to stop it. But this it works. Also, I can write data on these really big. For the time, really big volume. Yeah, and because that is working, and this is first included Fibre Channel hardware. Further on, maybe I will try a bit newer Fibre Channel switch from Compaq to connect it to all of the other machines, but maybe I have to solve. Maybe there is the AlphaServers need patches for running Fibre Channel, and wasn't successful patch here, so I have to find out what was the issue with the patch on the OpenVMS 7.3-2, and also on the back there are available also modular variables without a switch functionality, so it just connects the controller to the Fibre Channel to Fibre Channel, and maybe I will change these modules as well when I find some of these modules for a reasonable price. At the moment they are quite expensive on eBay. One module costs the amount of money I've paid for the whole system, so yeah, maybe there will be cheaper versions available, but this is all stuff for the future, because this is the end of that video, and the next video will take a while, because I have to spend some time for my PhD thesis in the future. So I think it will be next video will be released mid or end April. So yeah, it takes a while until my next video will be released. But yeah, you can enjoy that video and all my older videos if you haven't seen them. And yeah, you can leave comments down below, and see you the next time.